Hey, hello everyone. This is Abhijeet and I welcome you all to this today's session. In the last session, we have learned about the electric potential. Now in today's session, we are going to learn about potential difference. But before going to watch directly this video, please go and watch a last video of electric potential. Why? Because potential difference is based on electric potential. So please go and watch this video. So let's begin with the first point here on your screen. The difference in electric potential between 2 points is known as potential difference. Means if we have given two different values of electric potential, then we call it as potential difference. For understanding purpose, here we are taking the analogy of flow of water. So therefore here in this image, two beakers are given to us and these are filled with same water level, right? So therefore in this image, water in a perfectly horizontal tube does not flow, right? So this is a horizontal tube which is connecting to this A and B beaker, and in this perfectly horizontal tube there is a no any flow of water. Means the water present inside this tube remains stable. Why? Because these two beakers are at the same pressure, or also we can say these are filled with the same water level. Alright, these are the same water level, and due to the same water level there is also same pressure from the atmosphere. Okay, सो ॲटमॉस्फिअर कडून त्यांना जे काही प्रेशर इथं एक्झर्ट होते ते पण कसं आहे, सेम आहे. त्यामुळे ए मधलं वॉटर या कनेक्टिंग पाईप मधून बी मध्ये जाऊ शकत नाहीये, किंवा बी मधलं वॉटर या थ्रू द कनेक्टिंग पाईप मधून ए मध्ये जाऊ शकत नाहीये. ओके, ओनली रिझन इज व्हॉट? बिकॉज देर इज अ सेम प्रेशर, okay, on their respective water levels. Okay, now come to the second image. Here in this image you can see again two beakers, beaker A and beaker B. There is also again one horizontal pipe for connecting these two beakers with each other, right? But the only difference in that image is here in this water, beaker A water level is at high level from the base, and in the second beaker, that is the beaker B, the water level is quite low as compared to the beaker A. So therefore due to the difference in water level there is also difference in pressure from the atmosphere, right? So due to the different atmospheric pressure there is a movement or a flow of water through this horizontal pipe, okay, from beaker A to beaker B. And the same concept here we are going to use to understand the today's topic, that is potential difference. So here you can see a conductor which is of a copper wire, and this conductor is connected by the voltmeter at these 2 point A and point B. These 2 point A and B plays a role like a beaker A and B as in this second image. Okay, so now here we can see charges do not flow in a copper wire by themselves. म्हणजे हा जो कंडक्टर आहे या कंडक्टर मधून चार्जेस जे आहेत ते बाय देमसेल्स म्हणजे त्यांच्या स्वतःहून ते तिथून त्या कंडक्टर मधून फ्लो होणार नाहीयेत. कारण का? तर जसं इथं या इमेज मध्ये हे जे वॉटर आहे ए बीकर मधलं ते बी बीकर मध्ये थ्रू दिस हॉरिझॉन्टल पाईप फ्लो होत नाहीये, स्वतःहून फ्लो होत नाहीये. कारण का? तिथे प्रेशर जो आहे ते कसं आहे, दोन्ही वॉटर लेवलला सेम आहे. म्हणून त्यांनी काय सांगितलं इथं की कॉपर पासून बनलेल्या कंडक्टर मधून चार्जेस म्हणजेच काय रे, इलेक्ट्रॉन्स जे आहेत ते स्वतःहून फ्लो होणार नाहीयेत. मग ते कधी फ्लो होतील तर इलेक्ट्रॉन्स मूव ओनली इफ देर इज अ डिफरन्स ऑफ इलेक्ट्रिक प्रेशर, म्हणजेच पोटेन्शियल डिफरन्स अलॉंग दी कंडक्टर. म्हणजे या कंडक्टरच्या अलॉंग जर का ए आणि बी या दोन पॉइंटला इलेक्ट्रिक प्रेशरचा डिफरन्स तिथं क्रिएट झाला असेल, म्हणजेच तिथं पोटेन्शियल डिफरन्स या दोन्ही पॉईंटला क्रिएट झाला असेल, तरच ए पॉईंटकडून बी पॉईंटकडे काय होणार आहे, इलेक्ट्रॉन्सची मूवमेंट होणार आहे. सो देअरफॉर the action chemical action within a cell generates potential difference across the terminals of the cell. So मग आता हे potential difference आपल्याला समजलं की त्याचा पर्पज काय आहे. सर पर्पज काय आहे की जस्ट ए पॉईंटकडून बी पॉईंटकडे इलेक्ट्रॉन्सची मूवमेंट होण्यासाठी, या इलेक्ट्रॉन्सची मूवमेंट होण्यासाठी तिथं काय मेंटेन केलं पाहिजे, पोटेन्शियल डिफरन्स मेंटेन केलं पाहिजे. बट हे पोटेन्शियल डिफरन्स मग आपण मेंटेन कसं करणार, तर त्यासाठी हे दोन पॉईंट्स आपल्याला कुठे कनेक्ट करावे लागतील, तर सेल किंवा बॅटरीच्या पॉझिटिव्ह आणि निगेटिव्ह टर्मिनल्सला कनेक्ट करावे लागतील. तेव्हा काय होणार आहे, तर ते सेल किंवा बॅटरीच्या विदिन जी केमिकल ॲक्शन होते, ती केमिकल ॲक्शन काय जनरेट करते, पोटेन्शियल डिफरन्स जनरेट करते तिच्या दोन्ही टर्मिनल्सला, म्हणजे पॉझिटिव्हला निगेटिव्हला, आणि तिथून मग ते काय करते, पोटेन्शियल डिफरन्सच्या थ्रू इलेक्ट्रॉन्सला इकडे त्या कंडक्टरमधून मूव्ह होण्यासाठी अलाव करते. सो देअरफॉर पोटेन्शियल डिफरन्स मग काय करतात, सेट्स दी चार्जेस म्हणजेच इलेक्ट्रॉन्स इन मोशन अँड इन कंडक्टर, अँड देअरफॉर इन दी कंडक्टर प्रोड्युसेस इलेक्ट्रिक करंट. ओके, now come to the next slide. See here the definition of potential difference in the circuit between the 2 points. So the amount of work done in moving a unit charge from one point to other points, means as we have seen in the last slide, there are 2 points A and B, and between these 2 points there is a presence of conductor which is made up of copper wire. And if suppose for moving electrons from point A to B, त्या इलेक्ट्रॉनना इथं काय करावं लागते, स्वतःची एनर्जी तिथं त्यांना इन्व्हेस्ट करावी लागते, यूज करावी लागते, म्हणजेच त्यांना पॉईंट ए कडून अदर पॉईंटकडे जाण्यासाठी तिथं वर्क डन करावे लागते. मग ते वर्क डन कधी करतात, तर जेव्हा त्या दोन्ही पॉईंटला काय डिफरंट असेल, तर प्रेशर डिफरंट असेल, किंवा तिथं काय मेंटेन केलेलं असेल, प्रेशर डिफरन्स मेंटेन केलेला असेल, तेव्हा आणि तेव्हाच ते त्या पोटेन्शियल डिफरन्सला यूज करून ए कडून बी कडे जाण्यासाठी स्वतःची एनर्जी यूज करतात, म्हणजेच त्यांना तिथं वर्क डन करावं लागतं. आणि ते जेवढ्या अमाऊंटचं वर्क डन ए कडून बी कडे जाण्यासाठी तिथे यूज करतात किंवा वर्क डन स्वतः करतात, ते वर्क डन म्हणजेच काय झालं, तर या दोन पॉईंटचं काय झालं, पोटेन्शियल डिफरन्स झाला. So this is the simplest definition. If you wanna learn in more detail, then you can watch my last video of the electric potential. So now this statement we can arrange in the way of a ratio. So see here, potential difference is equal to work done upon quantity of charge moved. So now see, if the W joules of work has to be done, then we need to move Q coulombs of charge from point 1 to other point. Okay, so therefore then the potential difference between these 2 points is given by the formula, and the formula is V is equal to W upon capital Q. Okay, so here in this formula, capital Q stands for quantity of charge moved. Okay, means from one point to other point किती अमाऊंट ऑफ चार्ज मूव्ह झालेली आहे, किंवा किती अमाऊंट चार्ज तिथे त्या कंडक्टरमधून मूव्ह झालेले आहेत, ती क्वांटिटी किंवा ती अमाऊंट म्हणजेच काय, हा capital Q. Now then here W, capital W stands for work done, and this capital V stands for potential difference. Okay, and this formula you should remember for solving the numericals based on potential difference. Now then come to the next slide. Here you can see the SI unit which is used for measuring potential difference is a volt, and it is denoted by the letter capital V. Now this SI unit of potential difference is named after Alessandro Volta. Who is Alessandro Volta? He is an Italian physicist. Okay, so based on his discovery, the name is given to the SI unit of potential difference is volt. Now then the another symbol which we can use for representing potential difference is simple P dot D, small p dot small d dot. Okay, Now here is the definition of potential difference in the terms of 1 volt. Means simply if the potential difference is equal to W upon Q, and if the we have value of W is 1 joule and the value of Q is 1 coulomb, then obviously 1 upon 1 answer becomes 1 volt. So हा जो आता मी कन्सेप्ट सांगितला इन न्यूमेरिकल वे तो आता ह्या स्टेटमेंट मध्ये सेम सांगितलेला आहे. सो बघा, इफ 1 जूल ऑफ वर्क इज टू बी डन इन मूविंग 1 coulomb of electric charge from one point to other point. Okay, now then here this statement we can again rewrite in the form of ratio. So therefore 1 volt is equal to 1 joule upon 1 coulomb, and this ratio is comes from the formula of V is equal to W upon Q. Then here potential difference is measured by means of instrument, and the name of instrument is voltmeter. Here in the image you can see this is a voltmeter, and in the voltmeter this is the dial gauge, and with the help of this dial gauge and pointer we can get the values of potential difference in the unit of volt. And this voltmeter is connected in parallel, but where across the 2 points where potential difference is to be measured. म्हणजे ज्या 2 पॉइंटच्या आपल्याला पोटेन्शियल डिफरन्स मेजर करायचा आहे त्या ठिकाणी आपण या व्होल्टमीटरला कसं कनेक्ट करणार आहोत, पॅरलली. ओके, सो हियर इन द इमेज यू विल get clear idea of the application of voltmeter. See, here is the conductor of a copper wire, and here the 2 points of this conductor, and we need to measure the potential difference across these 2 points. So for that purpose here we can connect voltmeter which is parallelly to this conductor. Okay, and now after connecting with the help of this dial gauge and pointer we get the value of potential difference in the SI unit of volt, and this is the purpose of voltmeter in the electric circuit. Now here the again some important points regarding the voltmeter. Voltmeter has a high resistance, means it has a high opposition to the acceptance of electric current, and so therefore we can say it takes a negligible amount of current from this circuit. Okay, now here the term volts gives the rise to the another word, and the word is voltage. Okay, and the voltage is also the another name of potential difference. Means if the in exam you are given by the word of voltage, then the voltage and potential difference has the same sense. Okay, so don't get confused in your exam for this word voltage. Now in the next video we will be discussing about some numericals based on potential difference. So that's it guys for the today's session. If you have any doubts, any queries, then you can ask me, but for that you have to join the Telegram group, and the link is given below in the description and also here on your screen. And if you like this video, then please don't forget to subscribe and share with your friend. Thank you for joining us. Bye bye, take care.